So this lesson is on linear functions and how to tell if it's going to be linear or not. So we're going to start off with what is linear function. It's a function whose graph forms a straight line. Pretty easy to remember because the first four letters of linear spell line. So linear just means it makes a straight line. So we're going to start off easy with graphs. This is a linear graph. It makes a straight line. A is a linear graph. It makes a straight line. It's linear. B is not linear because it's not a straight line. It curves and it curves. So B is not linear. Here it says identify if it's a function, and if it is a function, is it linear? So let's go through remembering how to tell if it's a function. So if you have a graph, you do something called the vertical line test. So I would draw a vertical line through this graph. And if it touches twice, remember it is not a function. If I had a graph like this, and I draw a vertical line, if it only touches once, it is a function. So that's your vertical line test. So let's look at these examples. A, if I draw a vertical line through this graph, is it a function? I hope you said no, because it touches there and there and there and there and there. So this one is not a function. I'm going to go ahead and do all of them. This one, if I draw a vertical line, it only touches once. So this one is a function. Here, if I draw a vertical line, it touches twice. So it is not a function. Okay, so that's the first part. If the graph is a function, is the function linear? So we're not even going to worry about it with this because it's not even a function. Here, this one is linear. It makes a straight line. This one is not a function, so again, I don't need to worry about it, but I just want to make sure you would see this is not linear because it curves. Okay, so graphs are real easy. What about equations? Well, if it's already set up in y equals, I think the easiest way is to graph it and just look at your graph and see if it's linear. Sometimes it's not in y equals, and these are the rules. You can't have an exponent other than 1. So like if I had y equals x squared, that's not going to be linear because the exponent is bigger than 1. If I had x to the third, it's not a function. X cannot be in the denominator. Let me give you an example of what that would look like. If I had y equals 2 divided by x, well, x is in the denominator, so that is not going to be a linear graph. X and y cannot be multiplied together. Here's an example of that right here. X and y are being multiplied, so it's not a function. Also, y cannot be in the denominator. So if I had 3 over y equals x, this is not linear because y is in the denominator. So these are the 4 rules. Or, like I said, if it's already in y equals, you can just graph it and you can look and see. So let's do some examples. Here, 1 is not in y equals form, so I'm just going to use my rules. Is there an exponent bigger than 1? Yes, it's an x squared. So this one is not linear. This one is nice. It's in y equals form, so I'm going to graph it real quick. You go to y equals, I'm going to type in 3x plus 5. I'm going to hit graph. Does that make a nice pretty straight line? It sure does. So this one is linear. Here, okay, so it's already in y equals, so we can graph it and look at it. So y equals, let's clear that out and type in 2 divided by x plus 10. Let's graph that. So this, you can tell from your graph, is not linear. Another way you could have done, if you remember from this list, it says the very first one, oh nope, the very second one, x cannot be in the denominator, and in this problem right here, x is in the denominator. So this one is not linear. Next up, linear or not linear, again, number 4 is in y equals, so let's just graph it and see. We got negative 2x plus 2. Graph it. And it is a nice straight line. So this one is linear. And again, let's just go through our rules. There's no exponent, so we're good there. X is not in the denominator. We're good there. X and y are not multiplying, and y is not in the denominator, so we're good there. This one is not in y equals. We could get it in y equals and graph it, but let's just go through our rules. Are there any exponents? No, so we're good there. Is x in the denominator? No, we're good there. Is x and y, are they multiplying? No. And is y in the denominator? No. So because it passes all of those tests, we know it is linear. Okay, what do we do if it's a table? All right, we're going to find the change in x and change in y and divide them. And if it's the same, then it's linear. You're probably like, what in the world? Let me show you. To get from negative 2 to negative 1, I go up 1. Negative 1 to 0, I go up 1. 0 to 1, I go up 1. 1 to 2, I go up 1. 7 to 4, I go down 3. 4 to 1, I go down 3. 1 to negative 2, I go down 3. Negative 2 to negative 5, I go down 3. All of the x's are changing by 1. All of the y's are changing by negative 3. It's the same, so I know it's linear. You don't have to divide if you get the same numbers on both sides. So I got all 1s on my x's and I got all negative 3s on my y's. So I don't have to do that division part. Okay, let's try this one. Negative 2 to negative 1 goes up 1. Negative 1 to 0 goes up 1. 0 to 1 goes up 1. 1 to 2 goes up 1. 6 to 3 goes down 3. 3 to 2 goes down 1. 2 to 3 goes up 1. 3 to 6 goes up 3. Now, again, all my x's are good, but are all of my y's the same? No, they are not. So this one is not linear. What do you do if they're ordered pairs? We are going to do it just like we did the table, okay? It's going to work the same way. I'm going to make a table. So I got 0, negative 3. I got 4, 0. I got 8, 3. 12, 6. And 16, 9. And then we're going to do it just like we did the last slide. 0 to 4, you go up 4. 4 to 8, you go up 4. 8 to 12, you go up 4. 4 to 16, we go up 4. So those are all good. Negative 3 to 0, we go up 3. 0 to 3, we go up 3. 3 to 6, we go up 3. 6 to 9, we go up 3. All my x's are the same. All my y's are the same. So this one is linear. All right, let's do example 7. Let's make a table. So, table, negative 4, 13 is my first ordered pair, negative 2, 1, 0, negative 3, 2, 1, 4, 13. So, negative 4 to negative 2, you go up 2. Negative 2 to 0, go up 2. 0 to 2, go up 2. 2 to 4, go up 2. 13 to 1, we go down 12. 1 to negative 3, we go down 4. Negative 3 to 1, we're going up 4. And 1 to 13, we go up 12. So, all my x's are the same. My x's are all up 2. My y's are not. So this one is not linear. Let's do one more example like this. Make a table. I got 3, 5, 5, 4, 7, 3, 9, 2, 11, 1. And let's find our change. 3 to 5, I go up 2. 5 to 7, I go up 2. 7 to 9, I go up 2. 9 to 11, I go up 2. 5 to 4 is down 1. 4 to 3 is down 1. 3 to 2 is down 1. 2 to 1 is down 1. All my x's are the same. All my y's are the same. So this one is linear. And that's it. So go try this worksheet. It's just, is it linear or not? Oh, one more thing I do want to tell you. Remember, and it's really just a refresher. Your worksheet is going to ask you, are these functions? And remember, to tell if it's functions, you look at your x's. So my x's were 0, 4, 8, 12, 16. If they do not repeat, it is a function. You need to know that for your worksheet. If the x's do not repeat, it is a function.